Hey, welcome back, geometry students. Can you believe spring break is over now and we only have 6 weeks of school left? In fact, because of the e-learning and everything, only 18 school days left, guys. I know we can do it. My plan is we'll spend about 3 weeks or about 9 days here in chapter 11, working on three-dimensional shapes and their surface areas and volumes, and then the last 3 weeks or 9 days working in the unit of studying circles in a great amount of detail. Okay, so I hope before you even start watching this video today, you go into Canvas and you have found that I've given you a reference sheet. I want you to download that into your iPad or even print it out if you have a printer at home, so you can be using that and referring to it as we go through the examples today and as you complete your homework. You'll find it very helpful, I hope. And notice there's a little key at the bottom of the reference sheet explaining what all the symbols mean, okay? I really encourage you also next on the reference sheet to draw a little picture of each of the shapes you're working with each day so you kind of remember what they look like and what the parts are referring to, okay? A good example of this prism that we're pointing to right now might be something like, you probably have a cereal box or a cardboard box laying around your house, and it resembles the shape we're looking at here. Now, prisms don't have to have all sides that are rectangles. Sometimes they'll have triangles on two ends or other shapes on the two opposite ends. And if the opposite ends are circles, you get this shape that we call a cylinder. That's going to be the topic for Wednesday. Okay, so let's go ahead and get started. The first couple of slides introduce some vocabulary and not kind of leading up to the nice streamlined way to find the total surface area of a prism. Okay, so now we're going to start by showing you two prisms, neither which are probably like most prisms you probably have laying around your house. Most cardboard boxes or cereal boxes aren't shaped like this, but this prism has a pentagon, in other words, 5 edges on 2 opposite ends, and so we would call that a pentagonal prism. This one next to it has triangles at opposite ends, and we would call this a triangular prism. What they have in common is that at each end of the prism there are 2 identical shapes, and we refer to those as the base shapes or the bases. And in your formula sheet that we're going to be using today, the area of those shapes is referred to with a capital B. Okay, so that does not make any difference what shape it is. You just need to find the area of that shape. Now, the most common ones and the ones we'll be using today will be where the base shape is a triangle or a rectangle. That would be the only 2 ones you'll probably see. Now, connecting those 2 base shapes are a series of rectangles, and the number of rectangles that are connecting the 2 bases corresponds to the number of edges that the bases have. So in this triangular prism, where there's 3 edges on each base, that means there's 3 rectangles that connect them, and those are referred to as the lateral faces. Sometimes you're asked to just find the lateral area, and that would literally just be the area of those rectangles. Okay. Well, let's go and talk about how to find the surface area of a shape like this. Now, a good way to start is actually to imagine taking your prism, such as, like your cereal box or a cardboard box you have laying around, and actually cutting it along a couple of corners and being able to unfold it. And we get what's called a net if we do that. Okay, so a net basically flattens the box into 2 dimensions where you can see all the rectangles and triangles or whatever shapes are making up the sides. So actually a very common way to do this, the total area of the box would literally be to just unfold it all, notice all the different rectangles or shapes you have, and literally just add up all of them. Now, and what's good is that quite often they will come in pairs that are identical, such as in this rectangular prism, right? You've got actually 6 sides. but really they come in three groups of two, right? Because the top and bottom of the box are identical, the left and right sides are identical, and then the front and back are identical. That's one way a lot of people solve the surface area problem, is literally just kind of list out the sides and find the area of all of them, add them together. Now, one thing the net also demonstrates is another approach to this. Let's start with just the lateral area, which is in this picture, the area of the four rectangles. Okay, so one way to think of it is they are all rectangles that have the same height, and that height is the height of the prism, right? That H. That's a common height to all of the rectangles. Now, what's different is the edges, the edge lengths of all these rectangles. But you notice after unfolding it, those edges, the ones marked A, B, C, D, all correspond to an edge of the base shape, which was that rectangle at the top, that blue rectangle. So each of these edges corresponds to an edge of this blue rectangle. So if you imagine adding those together, right, that's like adding together the four sides of this rectangle, which is the perimeter of that base rectangle. And so if you now want to see the yellow rectangles together as one large rectangle, and I know it's kind of bent here, but if you think about it, that's just one big rectangle. The one dimension is the height of the prism. The other dimension is the total combined perimeter of the base shape. So my quick way to get the lateral area is just to take the perimeter P, the perimeter of that base shape, and then multiply that times the height of the prism, H. Okay, so that would take care of all the yellow rectangles all at one time. And then to finish off the total surface area, we will take that quantity that we've already worked out, the lateral area, and we're now going to add on, well, there was a base shape at the top and a base shape at the bottom. And so we'll just find the area of that blue rectangle, and we're going to multiply it by 2 because there's going to be one at the top and one at the bottom. So I want to notice in your reference sheet, this is the way the reference sheet says it, to find the total surface area. Little p times little h refers to the perimeter of the base shape times the height. And then the capital B is the area of the base shape multiplying by 2. A common convention in the formula sheet is if the letter is a lowercase letter, it is usually a length, like a perimeter or a height. And if the letter is capitalized, it's referring to an area, okay, the area of some shape. Well, we have two examples to try here, and let's take a look at the rectangular prism first. Okay, so before we even start, I'm going to write my formula that we found on the last page. Surface area is perimeter of the base times the height plus 2 times the area of the base, which is capital B. And what I really find important here is just to make a list of the 3 things we don't know and see where we're going to find them in the diagram. Okay, so I make a list before we fill everything in. So the P, little p, refers to the perimeter of the base shape. Well, I'm going to highlight the base shape first. And that would be like this rectangle at the top of the box. It could also refer to the rectangle at the bottom of the box. Okay? But either way, that rectangle has one side of 4 centimeters, one side of 3, and because it is a rectangle, that will be repeated in the back and the side. Okay, so I'm actually going to copy them up here just to make it easier to write. Okay, so 4, 3, there will be 4 again there, 3 there. So little p refers to the perimeter of the base. So we're literally going to add 4 plus 3 plus 4 plus 3. I mean, some of you are going to see that as 4 times 2 plus 6 times 2. But if I add all that together, 4 and 3 is 7. Then I'm going to have 7 again. So this is going to be 14 centimeters for the perimeter of that rectangle. H refers to the height of the prism, which is always the distance between the two base shapes. So the distance between the two rectangles, two yellow rectangles, is this 5. Okay, and so there's nothing to calculate there. That's just from the picture, 5 centimeters. And now the capital B refers to the area of the base shape. So again, we're looking at the yellow rectangle. And for a rectangle, we remember that the area is length times width. And so this is just going to be 4 multiplied by 3, which makes 12 centimeters squared. And now I can just go fill in my formula, right? So I'm going to fill it in. Surface area equals P times H is now going to be 14 times 5. And then 2 times the base, that's going to be 2 times 12. And you may or may not need a calculator to do the rest here. If you grab your calculator and multiply 14 times 5, you're going to find that that is 70. And that 2 times 12 is 24. So my grand total is 94. And this is area, so it should be in square centimeters. Okay, hope you see how we have the formula. We wrote out what the 3 missing quantities were. 2 of them we had to calculate. The P was the perimeter of the base, so that was adding up the 4 edges of the rectangle at the top. The height, we didn't have to calculate, it was given in the picture. And then the capital B is the area of the base shape, and we had to multiply 4 times 3 to get that. Okay. The other one we have today is similar, except that the base shapes are going to be these triangles this time. Actually, let's go ahead and highlight the triangles right away. Okay, so these are going to be the base shapes. There's one at the top and one at the bottom. Okay. Now, there is one thing missing this time, and that is in the triangle, we only know 2 of the sides, and you know part of our surface area formula is that we have to know the perimeter of the base. So I'm going to write the formula again. Perimeter of the base times the height, and then the area of the base times 2. Okay, and we're going to make a list here of the 3 quantities we need, right? And you notice again, the one we don't really have to do much with is the height. It's right there. The height is going to be the 6 centimeters. Okay. I think the next one that's actually the easiest is the B, the area of the base. It's the area of this triangle. Now, if you need to, I could draw this triangle just on the side for a minute and turn it in a convenient way. Okay, where the right angle is there. I've got 3 here, I've got 4 there. And if you recall that the area of a triangle is base times height times 1/2, or divided by 2, this will just be 1/2. Area of that triangle is 1/2 times 3 times 4. Okay, and if I actually work backwards there, 4 times 3 would be 12, and then 12 times 1/2 will just be 6. Okay, and that'll be square centimeters. Now, I think the tricky part is the perimeter, and going back, so we're going back to the right triangle again, and the perimeter is not completely known yet because I only know 2 of the 3 sides. I really don't know this one. Okay, so in order to find the perimeter of the base, I'm going to have to find that. And fortunately, this is a right triangle, so we can just go ahead and use the Pythagorean theorem. And this is the hypotenuse it's missing, so it'll be 4 squared plus 3 squared. And you know what, let's just call this x for a minute, x squared. And this makes 16 plus 9 equals x squared. This is a common one. It turns out nice here. You get x squared equals 25, so that makes x 5. So now we know that the missing side's 5, right? That would make it a 5 right there too, and down here, right? And now the perimeter is easy. We'll just take 3 plus 4 plus 5. And 3 plus 4 is 7, and 7 plus 5 is 12 centimeters. So we're ready to fill it in. Perimeter was 12. Height was 6. And then the base was 6. This will be 2 times 6. All right. And so here we go. 12 times 6. We might need our calculator for that. Or let's see, it's 12 times 6. I think it's 72. And then 2 times 6 is 12. So my grand total is 84 centimeters squared. Okay, well, guys, today in Math Excel, I think there's about 4 problems or 4 or 5. They're very similar to these. You're going to have a couple where most of them, the base shape is a rectangle. You got one, I think 1 or 2 that's a triangle like this one is. Well, good luck with that. Let me know if you're having any problems. Please keep in touch this week. I look forward to hearing from you. Thank you.